This is the Destiny of Manufacturing podcast, brought to you today by the Precision Metal Forming Association and the PMA's Educational Foundation. Today with me, I have Dr. Jason Jones from Hybrid Manufacturing Technologies. He's one of the leaders and thought leaders within the additive manufacturing world. He's been a speaker at many of the SME events, including Rapid, and he has done an outstanding job of thinking outside of the box and bringing new technologies. So I'd like to bring in at this time Dr. Jason Jones. How are you doing, Jason?
Well, thank you, Dean. It's great to be with you this morning.
It's great to have you. Thank you for taking the time out of your busy schedule to be here with our audience and to help us get a look into the 5-year view of manufacturing and help our audience kind of gear their future to what additive can offer us. Please tell us a little bit about Hybrid and how you came to be involved with the company.
So Hybrid has its roots really from two industries. One is the CNC machining world, which is well established and well known, and the other is 3D printing. And the objective really was, how can we get 3D printing, how can we improve its availability? And the strategy we came up with was to make 3D printing capability available inside of a CNC machine so that the existing infrastructure for manufacturing could use it on the shop floor. And I was one of the founders, and I'm pleased to have a variety of products that do just that.
That's outstanding. Now, within that sector, can you tell us a little bit about where your technology fits in the additive world? I know there's different sectors within additive for different technologies based on materials and where yours fits, as far as, because yours tends to be on the metal side as opposed to what a lot of people sometimes think of as additive in a lot of the plastics world. Can you tell us a little bit about that?
Sure. So as you've referred to, additive has 7 different families of technologies per the standards organization, and each of them has different pros and cons. Our focus as a company when we started was on directed energy deposition, which is essentially automated welding and allows you to add metal onto existing parts and build features up, that sort of thing. So the technology that we've developed was not to invent directed energy deposition, but to reinvent it in such a way that it can fit and be compatible with CNC machinery. And that's been the core skill, really, that we've leveraged.
Yeah, and your technology, it fits so well with what the Precision Metal Forming Association does and a lot of the companies that we work with within that industry. And over the next 5 years, what kind of things do you see happening that will shape how we think of additive?
I see that additive has 2 fundamental challenges. One is that additive has existed as kind of in a standalone architecture. And the reason for that is because its first success was really in the prototyping regime. And so a prototyping department or a design department, wanted to be able to use it in a standalone format. And it's matured over the last 30 years, really with that application so preeminent that it's driven the architecture. And being standalone is great for prototyping, but it does not work for a manufacturing mindset. You've got upstream and downstream activities that all need to flow through, that point. And it doesn't make sense to have everything upstream and downstream manual from a automating and manufacturing line standpoint. So that's one challenge. It stands in isolation right now. The second challenge is that of the 7 different types of families within the additive world, those families do not talk to one another. That is, they don't, you use one type of additive, but you don't typically use 2 types of additive on the same part. And to me, that's a great opportunity to build. I think of it a lot like the early days of computing before the internet. You know, a standalone mainframe computer could do wonderful things, but then to have to print out literally the data and go enter it somewhere else wasn't very practical to get that cross-leveraging effect of multiple computers working together. And to me, additive, because each of those 7 families has different benefits and different material sets that they often use, to really realize the power of additive, we need to cross-leverage all 7 technologies and get the benefits to intermingle in a single product.
Right. I think that's a great view that you have of one of the challenges that the industry has been challenged with over, and this isn't just over the next 5 years, but it's even something we've been challenged with now. And one of the things that I see people have a mindset of is it's slow and it doesn't lend itself to high volume manufacturing. And I think people get into this box of thinking, where does it fit for my company and how can I use this in the future? And I see this as something that manufacturers can gain a lot from. You don't. It's not like you have to have 50 prototyping machines on the floor, but if that's what your volume dictates, then that's what you need. You know, I think in many ways you look at the same thing with CNC machines and machining centers over the years. You're only machining one part at a time. So you're limited on how much volume you can put out of that machine, whereas, people think in terms of stamping presses and equipment like that and the speed at which those go, the production numbers certainly are a lot higher, but it's not unusual to walk through a plant and see, 25 or 50 stamping presses, but nobody thinks twice about that. Do you see that manufacturers as a whole are starting to understand a little bit more about what the technology can do? Or do you feel like right now we're still in the phase of education?
I feel like the phase of education is really gaining inertia. I think that education phase will continue for a long time. I love the analogy you made with CNC machining, and it is true. CNC machining is a batch process, and the market has developed both ways to dramatically improve the volumetric removal capability, if I could describe it as that. They've also sought to reduce the cost of CNC machines so that you can have, a farm of CNC machines and parallelize the work so that you're doing a batch process but across multiple machines at once. And the development has gone both directions, right? Increased capability with more expensive multitasking machines and also reduce the cost so that you can multiply the number of machines and be able to get the throughput that you need. Additive parallels those two developments in that deposition rates from a volumetric standpoint have historically been much, much lower, an order or 2 orders of magnitude lower than what a machine can remove in the same amount of time. We're seeing that gap close. It still has a significant way to go, but it is closing. Conversely, the price of 3D printers is going down, and that then lends itself to having more than one 3D printing device to be able to address the volume that you would need. So, different value propositions exist for different parts, but both of those hold true. The reason I say that we're still very early in the education element for additive is because in addition to just simply improving the process, to really leverage additive, there's a whole nother dimension to it, and that is the design rules have to change to get the full value out of additive. And that didn't happen so much in the CNC world. We had been milling and turning and making parts for a long, long time, many decades before it was automated. And so automation did adjust the rules and certainly allowed additional freedoms, but it was not such a fundamental change in thinking. because the cutting mechanism, chip formation and those types of things, the physics were fundamentally the same. With additive, we can depart from what historically has been prismatic shapes. Well, why do we make prismatic shapes? Well, based on how a machine is set up, it's easy, right? It's the lowest cost, most efficient way to do it. Well, additive doesn't require prismatic shapes, and in fact, often it's less costly to build something that is not prismatic. And so as we get to these more arbitrary, free-flowing geometries, if we optimize things, often we have these parts that end up looking more like nature. They've got long flowing lines and curves and, elements that thin out and thicker sections and even variations in composition. So the material will change from one end of the part to the other. All of those things require both the imagination to know that it's possible and to want it, and secondly, design tools to be able to do it. And we need education and better tools at both levels to really get to what I believe will be a much better manifestation in 5 years of what's possible with additive.
Excellent. Do you think that, I think everybody is faced with the challenges of workforce development, and do you think that from your standpoint, from idea to part, is there a possibility here of shrinking down that time? Because, from a concept idea to building a design to then turning that into machine code at some point and being able to produce the part, quality control check it, and then making it to where you can make it as efficiently as possible to where the part you can have raw material into finished part as efficiently as possible and change over as quickly as possible to the next part. In which stages of that do you think the greatest gains are going to start coming from?
The ability to iterate and change design because it's digitally driven is a tremendous advantage. It's not exclusive to additive. The subtractive world also with CNC machining has that capability to be able to change things quickly. Anytime you move to tooling, then you have this tremendous penalty anytime you want to change your design. So yes, it's a great opportunity. Which of the different elements you've described is the most advantageous or valuable? It's a little bit hard to pinpoint. It'll vary, I think, a lot with the use case. But one thing additive has done is it has automated more of the preparation for the build. So people talk about, the idea of 3D printing, so many of the 3D printers don't actually print. They're not what you would historically call a printing technology. It's something else. But the term printing conceptualizes this, you push a button and it happens mentality. With CNC machining, the machinist still plays such a vital role. Even when you use CAM software, which automates the toolpath generation, they still have to make lots of decisions based on each feature. 3D printing itself has tried to remove the need to be aware of different features. It's tried to do this catch-all approach using software where you don't have to decide on a feature-by-feature basis how you do it. The methodology is the same no matter what, and so literally you push a button and that part gets sliced up into thin little wafers, and then every wafer gets printed with the same strategy, if you will. So the toolpath repeats over and over and over again, or at least the decision is, matrix is the same. So yes, it does bring the ability to make things closer to an individual. And I think that's manifest in the amount of time it takes, but even more so in the ease with which people can pick it up. I think that's why we see the adoption of 3D printing in schools and other areas at a much higher saturation level than CNC got to, because there's fewer decisions the designer has to make to 3D print something. That speaking at a prototyping level at least.
Right. I when I go and visit different colleges and universities that are using or have technology, have the additive, some level of additive on their floors and in the classroom. The one thing that does kind of brings out within the students is this level of creativity that is almost more of an art form than it is science, if that makes any sense. I think that the individual feels like he's more of the process, and because of that, and he can go from idea to reality in a different way than he would using a machining center or using a press brake or some other technology. Do you, when you've worked with some of these students and when you've worked in manufacturing, do you feel that there's more of this artistic end of the business that's exposed there?
I love working with people who are new to the technology. One of my favorite moments is when we commission one of our systems. Typically, we have a machinist who's accustomed to removing metal, and the first time they actually add metal with their same machine, a light turns on. And it's so fun to see that. And I would agree with you, there's this empowerment that comes. And certainly at a general level across all of 3D printing, because people have tried to embed some of the details of how things get made into software, it's less inhibiting. You have this freer feeling of, I can just go from this design to making it. Now, I'm not saying there are no design rules for additive. Plenty of things fail and aren't quite right and don't work. But it's less stringent from my opinion, in my opinion, than CNC machining or any other technique in terms of the requirements. And therefore, you have success earlier on with less training. And so that is part of the magic. Empowerment to creators.
I was privileged at Manufacturing Day last year to be at one of the universities, and they had a rapid prototyping competition. And I was really surprised by the variance in how they were using the equipment. Some people were it was using PLA material, just plastics, but other people were designing the tools, and we had some people that were using crucibles and melting material, and they were designing the molds as opposed to designing the actual part. And I was really struck by the fact that the invention took a whole different way from the students in the classes that they're taking, and they went in completely different directions in how they were going to use the technologies. And because of that, I think that we have more people getting into the industry, getting into manufacturing, that otherwise would not have done that in the past. And it probably was the first time that I could really see a value to switching from, the STEM curriculums to STEAM, which adds art to that formula, if you will. And, STEM, you have science, technology, engineering, and mathematics, and now you're adding art to it. And have you noticed that it's brought people in that otherwise would not have been in this industry?
Absolutely. Because the path to making something is, in my opinion, the shortest it's ever been. And particularly in polymers and materials, as a kid, I loved to make things. You could easily make things out of wood. You get a hold of those tools. But to make things in polymers or polymer composites or metals or other things, it just required a higher level of equipment and support than it does now. And so it's just so enabling that people who are curious, who want to be inventors, can express that and get to a result without what has historically been months and years of training, and as you observed yourself, by bringing new blood in and constraining them less, you get just this explosion and myriad of expressions that aren't anticipated by people who have been more formally trained for years and years in manufacturing, because the costs have been so high of a mistake. Everybody tends toward conservatism in manufacturing. I shouldn't say everybody, but the training and education you receive, infuse a portion of conservatism that isn't there when you have success so early.
Right. I wonder sometimes about how that creativity can be improved upon. I think that additive is equivalent right now to when the computers started having the availability of GUI, or graphic user interface. Before, when you were in computer science, you had to know an awful lot about computers to even make them do anything. And now, anybody can pick up a computer, a phone, a tablet, and just they see the object that they want. They just touch it on the screen, and it comes up. And it going back 20, 30 years, that was not the case. Going back, I'm dating myself now, but to when I was in high school and learning computers in the early 80s, late 70s, that technology hadn't quite gotten there yet, and which made it inaccessible to the average person. The change of that made it accessible. And I think that's another word that is really important now is with 3D printing allows accessibility. Do you see that changing the workforce more and shifting people in is because of the accessibility of the technologies?
Definitely. And I think that's why, so much of our dialogue is centered around students and early adopters and those types of things. If I could switch to a different group, which is the incumbent workforce that does, in our case, we're focused on metal. And so many of the CNC machinists that now are running CNC machines, there's been a wave of hype where there was fear that they would lose their jobs because of these 3D printers. And I believe that wave is largely dissipated now. And people are starting to understand virtually everything you print in metal. The surface finish is not comparable to CNC machining. It's typically an order of magnitude worse. And so to get to the surface finish and to meet the tolerances that we're accustomed to for mating parts and threads and all those types of things, these 3D printed metal parts end up on a machine tool. And so the accessibility, I think, reaches to the existing workforce and calls out to them just as loudly and perhaps more so than the incoming generation to say, embrace 3D printing. It's available for you. It's accessible, and their skills we are finding are perfectly complementary to help allow 3D printing to thrive. A message that CNC machining is a necessary prerequisite and undergirding technology for 3D printing is not something we discuss in those terms, but it is. And so it's been very satisfying to see machinists embrace 3D printing, whether it's on separate devices or within their own machine as we're focused on. It's just exciting to see that.
Right. Well, it's amazing that our time has gone so fast today here, Jason. Thank you so much for being part of our podcast. This is the Destiny of Manufacturing podcast, brought to you by Longevity Industries and the Precision Metal Forming Association and the PMA's Educational Foundation. I have been your host, Dean Phillips, and we thank you and have a great day.
My pleasure. Thank you.